S. Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Welcome to S. Chand Academy, and I am Anmol Bhatia. We are doing the course which is Engineering Mechanics, and the topic that we are doing in this video would be certain problems related to the concept of rigid bodies.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box.
So we would be coming to the problem straight away. So this is particularly a case in which there is a truck which is moving, and the question says that it is moving with the speed of 10 meter per second. In the truck, the brakes were applied, and that causes the wheels to stop rotating. So the two wheels would have the fixed distance in between. It would be treated as a rigid body. It is observed that the truck is skidded to stop in 7 meters. So there is a skidding in the truck. It is being observed. And what we need to determine the magnitude of the normal reaction and the frictional force at each wheel as the truck skidded to a stop. So that means we need to find out certain reaction forces, and there are certain tangential forces acting on the surface. Considering the weight of the truck, which is at the center, so the center of gravity of the truck will be at the center. Now, the solution, as far as the solution is concerned, we have to calculate the acceleration during the skidding that the truck has stopped by assuming the uniform acceleration. So you can see that this acceleration is this, and the truck is moving with the particular velocity. So this particularly is the formula which is associated, and initial velocity of the truck is mentioned that it is 10 meter per second. So we have to substitute 10 meter per second here, plus 2a remains the same, and this x minus x naught will be the distance, and that distance is the 7 meters mentioned. So this distance, if it is mentioned that it is that it has taken 7 meters to stop in, so 7 meter we have to substitute, and considering this velocity as 0, so from there this acceleration can be determined, or this a term can be determined. So this is minus 7.14 meter per second squares, and what we need to do, we need to draw the free body diagram for finding out the forces now. So you can see that the two tires which are there. So the first tire I name it as A, and the second tire I name it as B. And there are certain components of the forces which are there on the surface of these tires. One Fa, and another is the normal reaction on the surface of this A. Then B, Fb, and the normal on this B. And it has a fixed distance. Additionally, the center of gravity would have that particular value of weight. So what we need to do, we have to apply the scalar equations. So sum of all the forces in the y direction, that is to be considered, and we need to put it equals to 0. So upward force is considered to be positive, and the negative and this downward force is considered to be the negative ones. So here in Na and Nb are the two forces which are upward, and W is the downward force. So that is W, and we need to put it equals to 0. And secondly, sum of all the forces in x direction, additionally we have to put it equals to 0. the force which is moving towards the right hand side is considered positive, otherwise it is considered to be the negative one. So the other side is a negative one, so minus Fa and minus Fb, that is equal to minus Ma. Ma is the force with which it is moving. So this force is this frictional force, so F equals to mu into R, or you can say the normal reaction. Here also mu into Nb, and that is equal to Ma. So M is W by G into A. So on solving, we'll get this value of this mu component, and that component value is coming out to be 0.728. So additionally, we calculated this value of this coefficient of friction from this force part. Then what we need to do, we have to apply the same concept in order to find out the moments. So the moment which is in particular direction, which is the anti-clockwise direction, that is considered to be positive, otherwise it is negative. So distance and force multiplication would be taken into consideration. So 1.5 multiplied by this W, 3.6, which is the total value, multiplied by this NB, and 1.2 M. 1.2 M is this for the overall body, multiplied by the mass into acceleration. We'll substitute this value so that this NB, NA, and that rear force or the other forces for the front and the rear can be calculated. So same formula will be using mu into N. Here also that half into NV, mu is 1 by 2 for that particular front component. So we can find out all these forces as required in the question. So as required, we can find out the cases. We can find out the value of the normal forces and the reaction forces as required in the question. On putting in the values, that can be easily calculated. Now we'll look at another problem, which is sample problem number 2. And this problem has a cross section, which is a rectangular cross section, maybe of it is having the dimensions of 500 by 200, and it is being joined with the help of the two hooks, which are inclined an angle of 30 degree, and additionally it is also clamped with one hook which is H, and that is with the perpendicular direction with the surface. So you can see that in the question it is mentioned that you have a thin plate of mass 8 kg. So the mass is mentioned as shown. As shown means the diameters, the dimensions and other aspects are shown particularly in the question. Now what is mentioned, you have to neglect the masses of the links. So there are links, you have to neglect the mass of the links and determine immediately after the wire has been cut. So determine immediately after the wire has been cut the acceleration of the plate, and B is the force in each of the joint. If you can say that the wire is being cut, this wire is cut, so what would be the value of acceleration in the plate and the force in each link? So for this, again, you need to have the particular concept of sum of all the forces in x direction, y direction, and the movements associated, as we did in the previous aspect or the previous part of the question. So as far as the solution is concerned, if you can say that the wire is cut, so all the particles will move along a plane which is having the circular path of the radius, which is 150 mm. So 150 mm was mentioned. So when we cut that wire, it would move in a circular path. So as per the joint or as per this configuration mentioned. What you need to draw? You need to draw the free body diagram so that these force components can be extracted, and then you need to resolve them into the directions so that the acceleration can be determined. So herein you can see that the distance is mentioned 250, 200. Those distances are mentioned, and the center of gravity is also mentioned with an angle of 30 degree. So you have this A which would having the force component FAE, and you have D which is having the force component FDF. So this W, which is the weight which is acting downward, is having an angle of 30 degree. So you need to you need to convert it into one segment, and that segment would be W cos 30, and that is equivalent to the force component, and that force component is MA. So W is mg cos theta equals to MA. On solving, we'll get the value of that acceleration, which is coming out to be 8.5. So we need to use that value. Now, sum of all the forces which are to be considered, as I have told you in the previous part also, that this anti-clockwise type of movement is considered to be the positive one, otherwise it is the negative one. So here you have one force component which is FAE. You have FAE in two components. One is the cos component, and another will be the sine component. So sine component and the cos component. The sine component is with this direction, and the cos component is with the distance, which is 100 mm. And then DF part, this DF would also have the two components. One is the cos component, another is the sine component. So one is the sine component, another is the cos component. The sine component is with the distance 250, and the cos component is with the distance 100. So on solving, you'll get an expression which is giving you a relationship between FDF and FAE. So you get this expression particularly. Then you have to look for the forces which are there. So one force which is there is FAE. So FAE is particularly in this direction. So we have considered this direction as a positive one. So FAE is this in this direction, FDF is there in this same direction. So FAE, FDF, two directions. And the third direction is the sine component, which is W sine 30, which is acting in the downward direction. And that is particularly equals to 0. FDF's value can be replaced with FAE, and on solving you can easily get the value of FAE and FDF. So this was what was required. So you need to find out the value of the force component with which, when we cut the rope, it would move in with what forces. So this is what we call as a procedure to solve the problems of that rigid bodies. So we stop here for a short break. After coming back from the break, we will learn the concept of this rigid body concept with the help of more problems.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy, and I am Anmol Bhatia. We are doing the course Engineering Mechanics, and particularly we have learned the concept of rigid bodies, the angular momentum associated with rigid bodies with the help of certain numerical problems. Now we will go more into the details with the help of more such problems. As of now, we have done two problems which are related to the rigid body concepts. Now we'll do two more problems which are related to the same concepts. So the problem is like this. We are having pulley weighing systems, and that is having two pulleys with the dias mentioned, the radius mentioned. First one is having a radius of 150 mm and another one is having a radius of 250 mm. And the first pulley is carrying a weight of 5 kg and the second pulley is carrying a weight of 2.5 kg. And the pulley mentioned here that weighs 6 kg and having a radius of gyration of 200 mm. So 200 mm is the radius of gyration of this pulley, and that is connected to two blocks as shown. So this is a connection, and that particularly is connected to these two blocks mentioned are the weights and the distances there. Assuming that there is no axial friction, there is no friction from the axial part, we need to determine the angular acceleration of the pulley and the acceleration of each block. So each block has a particular value of acceleration that particularly we need to find out, and we need to find out the angular acceleration of the entire pulley. The procedure is similar to what we have seen in the previous cases. So first and the foremost, we have to look for sum of all the movements that the pulley undergoes. So this is having a usual notation, which is having the clockwise movements as the positive ones. So what we have this mb into g. So this mb into g would be the weight of this block. So mb is required, and g is the acceleration due to gravity multiplied by the distance that it has. And on the opposite side, you have this 2.5 kg mass multiplied by this 250 mm. So on solving, you can find out this mass, which is in the upward direction. So mass is there in the upward direction because it is shown positive. So as this rotation is counterclockwise, because it is counterclockwise and it is positive, so the value of I is I equals to mk square. So we have the value of mass and we have the value of this constant k square. So we can substitute this value in this particular relationship so that this I can be determined. Now what we need to find out, we have to find out what is the acceleration values in those two blocks. So acceleration values have this formula, which is angular acceleration into the radius, and for the second case is angular acceleration into the radius. So the radius is mentioned, 250 can be converted into 250 mm can be converted into meters, so that would be 0.25 meters multiplied by the angular acceleration, and here also 0.15 meter, 150 mm can be converted into meters multiplied by that angular acceleration. So what we need to do with that angular acceleration value, we would be using that angular acceleration value in the next equation. But before that, we have to make that free body diagram of the associated figures. So we have this 5 kg, 2.5 kg, and all. On solving it, we have this mb into that acceleration, ma into that acceleration, and this I alpha will be the and in moment of inertia multiplied by that angular acceleration, and this weight, which is 6g, and this associated reaction, that would be equivalent. So on applying this sum of all the moments concept and putting it equals to 0, we'll get this final expression like 5 kg multiplied by the acceleration due to gravity multiplied by the distance. Distance in meters is mentioned. For the second case, 2.5 multiplied by 9.81 into 0.251. So that is equivalent to I alpha plus I alpha is this value plus mb into ab multiplied by the distance minus ma into aa multiplied by the distance. So these two are having the similar expression. These two would be having the same set. So on solving, I'll get an expression. On putting in the values, I'll get the value of this alpha as 2.41. Now the moment I obtain this value of alpha, I can substitute that in this acceleration formulas, because it was required to find out the value of acceleration for the component A and for the component B as well. So we can substitute the value of alpha here, we can substitute the value of alpha here. So on substituting, I'll get these two values, which is A and AB. And if this I term is given to us, which is 0.24, I can find out. I had this AA value, so I can substitute the value of alpha and get the value of acceleration. So what was required in the question? Let us have a look. It was required to find out what is the value of angular acceleration. That means alpha was required. So alpha we have calculated from equating the moments together, and the second thing that was required is acceleration. So acceleration for the component A and acceleration for the component B was required. So it was dependent on angular acceleration. So we have substituted the value of angular acceleration and determined the value of this final part. We have another problem that is to be taken into consideration. So this is one of the basic problem, and that might be important from the point of view of the examination, and that is having a disk, and this disk is having a mass of 15 kg, and the cord is wrapped around that disk, and this cord is pulled upward with the force of 180 Newton. So this force is 180 Newton, and the cord is pulled upward. The mass of this disk is 15 kg, and this radius is mentioned to us as 0.5 meter. Now what is required and what we want to find out, determine the acceleration of the center of the disk. So at the center we need to find out a value of acceleration and the angular acceleration of the disk and acceleration of the cord. So one, we need to find out what is the acceleration at the center. Second, we need to find out what is the value of angular acceleration, and third is related to the cord. The acceleration of the cord is also determined, is also required. So the solution lies in the same concept that we have learned so far. If there are sum of forces lying together, so we have to undertake the sum of forces in x direction, in y direction, and we need to put those sums equal to 0. And additionally, if there are moments, so we need to put the sum of all the moments and put it equals to 0, so that what is required, that can be calculated. So herein we need to form the free body diagram. So free body here is this disk with the initial tension as T and is having a radius R with the particular weight which is W. Now this is equivalent to another set which is this category, in which it has this I alpha movement that we have already illustrated this with the help of the previous example, and we have two directions. One is acceleration in the x direction and another is the acceleration in the y direction. So both of them are the masses part. Now we have two categories. One is sum of all the forces in x direction and another is the sum of all the forces in the y direction. So this we know that the sum of all the forces in x direction, we have to keep the sign convention as positive if it is towards the right, and if it is upward we have to keep that a positive one, otherwise a negative part. So herein we have only one part of the force which is max, and that is equals to 0. So on solving we can say that this acceleration in the x direction is equals to 0 because mass cannot be 0. Then sum of all the forces in the other direction, which is sum in the y direction, which is this tension which is in the upward direction, that we have to consider positive. Another is this W that we need to consider as negative, and this force which is MAY, that would be the positive one, and that is to be taken on the other side, which is MAY. So on solving, this acceleration with the y part can be calculated. So we can put in the value of this T which is given to us, W and M, all these values are given to us, and from there we can find out the value of AY. So we got the two categories or two values of those accelerations. Additionally, the third thing that we have to do is considering the sum of all the movements equals to 0. So herein we have the first movement which is T into R, this is the one, and we have another movement which is equivalent, that movement is I into alpha. So this I into alpha movement. So this movement would be there in the clockwise direction. So anti-clockwise direction we have to consider positive. So this one is negative. Here I is there for the disk. So the value of this moment of inertia is half mr square. So we need to put in the value that half mr square multiplied by that angular acceleration. So on equating or on solving these particular values, we can get the value of alpha, which is minus 2t by mr. So we have the value of t from the question, which is 180. Mass we have 15 kg and that radius is 0.5 meter. That is mentioned in the question. That is 0.5 meter. The value of t is also mentioned and the mass is also mentioned. So we can substitute all these values so that this angular acceleration can be determined. So what we have calculated? Acceleration at the center we have calculated. Acceleration, the angular acceleration of the disk, that means alpha, we have calculated. And for the chord, we have to calculate now. So the third part, which is to determine the acceleration of this chord which is there. So the chord that is there would be having the tangential component of the force acting on the disk. So this tangential component or the chord part is equal to this acceleration plus the acceleration which is there with the from this A to G part, or from the A to G part which is tangential. So one component that we have already seen in the previous aspect, that is 2.19, which is in the y direction. So that is already there, and its effect, which is with the chord distance and the angular velocity, that is to be taken into consideration. So for the chord, we have calculated this value, which is 26.2. So the chord would have an effect which is due to the y component of the acceleration, which is already there. So that y component of that acceleration is to be added. So what we got? We got this x component of this acceleration as 0, y component as 2.19, and for the chord, that angular acceleration value is 48 radian per second square already, and the acceleration in the chord we have calculated like this. So with this, we come to the end of the video, in which we learnt the concept of rigid bodies with the help of certain numerical problems. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.